Alright, so first one is expanding. So we're taking a single log and making it be bigger. So we get, first off, we expand this to be log base 4 of 3 plus log base 4 of x squared. But then, because there's a power in that second one, that one would then become plus 2 log base 4 of x. That's the expanded version of that one. Natural log of 5t minus the natural log of 2s cubed. Okay? So the first one becomes the natural log of 5 plus the natural log of t. And that's what this one becomes. Now this one is a little trickier because it's minus the natural log of 2 and minus the natural log of s cubed. Because they're both in the denominator, they are both being subtracted.
We're not done yet.
No, we're not.
Okay, that's fine.
Nope. But we got to get that double minus sign first. Okay? So then this becomes the natural log of 5 plus the natural log of t minus the natural log of 2 minus 3 natural logs of x. Is what that becomes. Questions on those two? We had some issues yesterday, actually I shouldn't say yesterday, on Monday in the formative with condensing logs. When you are condensing logs, you are getting it down to one single solitary log. If you have more than one log in your final answer, you haven't condensed it enough. Okay? You're going to watch the Brewers in Milwaukee by stopping in Fond du Lac. Okay? You're not there yet. And you got to get all the way there. Okay? So first off on this one, this would be log base 3 of 5 minus, I can take this 2 and I can put that power property, go in reverse of the power property there, and so then this would be log base 3 of 7x squared. But I still don't have one single solitary log, but I can write this as log base 3 of 5 divided by 7x squared. Natural log of x to the 5th plus the natural log of 4 squared minus the natural log of 3 cubed. These two would then become the natural log of 16x to the 5th minus the natural log of 27 becomes the natural log of 16x to the 5th over 27. Okay? Questions on those two? 4 squared. This 2 goes into an exponent up here. Okay. What I'd like you to do now is I'd like you to take a couple of seconds to read through the bottom of page 1. Now, I'm going to put a big old star by this method, okay, because it's going to be your preferred method. Okay? I know it already that it's going to be your preferred method. Okay? What you do in this one is what we've been doing. We've been doing this for a while now, is first we change forms. So if it's an exponential, we switch it to logarithmic form. If it's a logarithmic form, we switch it to exponential. Okay? We change forms first. Okay? Then that allows us to use the change of base formula, okay, to solve for our variable. Okay? Quick, simple, effective. Okay? Promise you're probably going to go to that 99.4% of the time. Okay? An alternative method, if that's not your cup of tea, if that's not your jam, okay, then there's an alternative method. Same problem, we can first take the log to both sides. Then we can use the power rule and then divide both sides by a log. Okay? The second method down here is basically method number one in 2 more steps. Okay? So it's not going to necessarily be your preferred method. Okay? It's more efficient to do it the gold star way. Okay? But we'll get to there in a little bit. Okay? Now, there are 3 different types of logarithmic / exponential, up 4, 5. There's 5 different types of problems. Okay? We're going to work through them right now. Okay? We're always going to come back to this when we're solving, because that's how we solve exponentials or logarithmics. Okay? So the first type is when the bases are the same. Okay? Or you could rewrite them so that the bases are the same. Okay? We can do this 9 to the x power equals 29 because I can say that 9 is 3 squared. To the x power is going to equal 3 cubed. So basically, we've rewritten this equation so that we have 3 to the 2x power equals 3 cubed. Shouldn't be setting the world on fire. We've done this problem once or twice already this year. Okay? And then from here we say what? Because I have equal bases, I got to have equal exponents. So I would say 2x equals 3. So x would be either 3 halves or 1.5. Yes? Okay? Now, same problem, except I'm going to do it the gold star method. Okay? The first thing that I have to check in order to apply the gold star method is, do I have either the log or the exponent isolated? So in this case, it's an exponential. Do I have it isolated? No, nothing extra out in front, nothing below, nothing behind, nothing above. Yes? Okay, isolated. So then I can switch forms. Okay? So what is 9 to the x power equals 27 in logarithmic form?
log 9 of 27
Log base 9 of 27 equals x. Okay. And now I can go to my calculator and I can say, okay, I could go log, base 9 of 27. It's going to get me 1.5. Or I can go with log of 27 divided by log of 9. Or I could go natural log of 27, natural log of 9. Oops, why did my 9 go away? Okay. So no matter which way I do it, I get the same thing. What I'd like you to do now is I'd like you to do number 2. No matter which way I do it, I get negative 2/3. Which, if I was doing a change of base formula on my calculator, since we round to 3 decimal places, would be negative 0.667. Okay? Questions on that? Form number 2 of problems is when we have a log on both sides of our problem. Now, notice that it's log equals log. There's nothing else added or subtracted or multiplied or anything like that. It's just log and log. That's it on either side. Okay? So when you are in a log versus log case, there are 2 conditions that need to be met. Condition number 1 is you need to have equal bases. So the base of one has to be equal to the other. If that's the case, then in step number 2, then you can say that the arguments need to also be equal. Okay. Now, this works either going, if you have step 1, like in problem number 1, I have equal bases. So because I have equal bases, then I have to have equal arguments. In problem number 2, 3 to the 4th is really 81. So if I have equal arguments, then I have to have equal bases. Okay? So it works out either way how you do it. You either have to have condition number 1, then that gives you condition number 2, or you have to have condition number 2, that then gives you condition number 1. Okay? So solving this one, I would add 3 to both sides, so 4x equals 16, and then divide by 4, so x is equal to 4. Now, on the other one, I'd add 2, 3x equals 9, divide by 3x equals 3. In both cases, I need to make sure then that my answers work by plugging them back in. Because there are two conditions when I'm dealing with logs that always have to be true. Okay? What do we know in a logarithmic? What do we know about the base? In all logs, what has to be true about the base? Nope. It has to be what, Bruce? It has to be positive, but what? Not equal to 1. And in all logs, what do I know about the argument? Has to be what, Maggie? It's got to be positive. Can that one be equal to 0? Can my argument be 0? Brett? No. Can't be 0 either. Okay? So can't be 0 there. Okay? Can it be equal to 1? Yes, my argument can be equal to 1. Okay? So you got to go back and you got to check them. Okay? Now, type number 3, the third type of problem where the exponent is unknown. Okay? In this particular one, this is going to be the majority of your problem. I shouldn't say majority. It's probably going to be about 50% of your problems are going to be where the exponent is unknown. Okay? Right? So this again was the gold star method. Okay? Switching forms, using change of base, going through. Okay? This method over here is the log both sides method. Gets you to the same spot, okay? But it's more efficient to use the gold star method. Okay? Now, not every problem is going to be nice, neat, and wrapped with a bow on it for you to unwrap. You might have to do some work in order to do some problems. Okay? The first thing is, when you're doing this third type of problem is, you want to have your exponent term equal to some number. And that's it. You don't want anything else. You want to isolate that exponented term. So like in 4 to the x minus 3 problem, then minus 5 equals 16. First, I would have to add 5 to both sides, which then would give me 4 to the x minus 3 power equals 21. Now, I could take the log of both sides if that's the method I choose, or you could use the gold star way, and you could switch forms. If I switch forms with this one, what is the logarithmic form of this equation now? Bryce? Log base 4 of 21 equals x minus 3. And what can I do now? Even before that. But because I can't add 3 to the 21. It does not not become log base 4 of 24? Figure out what log base 4 of 21 is, right? Okay, so on your calculators now, figure out for me what log base 4 of 21 is. Logic tells me that it should be bigger than 2, right? Because 4 to the second power is 16. Okay? I get 2.196158711. We're going to round that to 3 decimal places, though. Okay? And that's going to equal x minus 3. Now what can I do? Now I can add 3. So I get 5.196 is equal to x. Right? Logic now says, okay, 5.196 minus 3 is going to be something a little bit bigger than 2, right? 4 to the power of something a little bit bigger than 2 is going to be a little bit bigger than 16, right? Minus 5 then hopefully gets me 16. Yes? Okay. Check it on your calculator. So 4 raised to the 5.196 minus 3 power is going to equal that. Then minus 5 is going to be that. Yes? What's wrong?
You don't need the minus 3.
If I'm checking 5.196, I need the minus 3. Because the problem was x minus 3, and that's what x is. So yeah, so I need the minus 3. But there's something else that's wrong. What else is wrong with this problem? It's not 16. But it's not 16. So how come it's not 16? Because we what? It's an R word. We rounded to 3 decimal points. Okay? If I were to do this with using the entire on the calculator, leave everything on the calculator, I would get 16 then. Okay? Because I would go log base 4 of 21 gets me that. So then I would take 4 to that power. Is this one, which gets me 21, then minus 5 gets me 16. Okay? Okay? The more times you round, the farther away from your answer you're going to be. Okay? So only round 1 time. Okay? Look ahead in the problem to see where you need to round, or where you should round. And it should be towards the end. If you round early, then you're going to be off. Okay? Try those two. In the first one, I get 9.585 when I round to 3 decimal places. Okay? When I check it, I get like 29.99 something. So it's pretty close, but because of the rounding, I'm off by that little bit. Okay? When I check the other one, 2 raised to the answer, and 7, wait, because I rounded 2.302 times 3 gets me that. 2 raised to the answer gives me that. minus 40, I get 799.48. Okay, so close, but again, because we rounded, the bigger your numbers get, the farther away you get. So, okay. Switch forms. Switch forms. Switch forms. Okay. Fourth type of problem, when the argument is unknown. Okay. Again, it's the same two methods. Okay. But if you compare the two methods, which one looks a little easier? Well, what is the first one? What do we?
You just change from
The gold star method. Okay? Right? You just change forms. As opposed to applying the change of base and then dividing by log, and it's brutal over there. But so again, you just wanna change forms. Get the log isolated and change forms. So you need to get the log isolated first. Okay? Okay? Bryce, you probably want to wake up and pay attention to this now. Okay? So, first one, log base 2 of x squared minus 6x equals 4. Do I have the logarithmic term isolated? Do I have it isolated? Yeah, there's nothing behind it, there's nothing in front of it, there's nothing below it, there's nothing above it. Okay? So the log term is isolated. So I've got log equals number, which is what I want. So now what do I do? Megan? Change forms. So if I change forms on this one, what do I get? Megan? 2 to the 4th power equals x squared minus 6x. What's 2 to the 4th power? 16. So this is really 16 equals x squared minus 6x. Now what? Set it equal to 0 because I have a squared term and a linear term. I have to get it equal to 0. Easier to move everything to the right or everything to the left? To the right, okay? So we get 0 equals x squared minus 6x minus 16. Now what? Factor it. Okay, what does it factor to be? Two numbers that multiply together to be negative 16 and add to be negative 6 or negative 8 and positive 2. Now what? So I said x minus 8 equal to 0. Gives me x equals 8. And I said x plus 2 equal to 0. That gives me x equals negative 2. Now what? Okay, which one do you want to pick? And what do I do with that then? Okay, x squared, or so 8 squared, 64. 6 times 8, 48. 64 minus 48, 16. So this becomes log base 2 of 16 equals 4. What is log base 2 of 16? Is it 4? Okay. What exponent do I put on 2 to get me 16? 4. Okay. So this is 4 equals 4. Does that check out? Yes. Okay, that one works. So that one's good. Now what? Plug in the negative 2. Okay? Negative 2 squared. Positive 4. 6 times negative 2. Negative 12. Positive 4 minus negative 12. 16. So this becomes log base 2 of 16 equals 4. Following the same logic, that one's going to check out also. So both of these work out. Okay? Even though, Skylar, I had a negative number here, my argument was still positive when I plugged it back in. So it's still good. Okay? Just because you see a negative sign doesn't automatically mean it's gone. Okay? You gotta check. Gotta. Okay? Alright? You try number 2. Do I have it isolated? No. So what do I gotta do first? Add 8 first. So that gives me 2 log base 6 of x squared plus x equals 2. Do I have it isolated yet?
No.
What do I got to do?
Put 2 on 6.
Divide both sides by 2. Do I have it isolated?
Yes.
Now that I have it isolated, now I can... So what do I get, Jacob, when I change forms?
6 equals x squared plus x.
So I get 6 to the first, right? Okay, and then that equals x squared plus x, right? Or if you just wrote it as 6, that's fine, because we rarely write an exponent of 1. Okay, right? So, now what do I do? Set it equal to 0 first. I can't factor yet. I gotta set it equal to 0 first. So I get x squared plus x minus 6. Okay. X plus 3 and x minus 2. Then what? Now what? Plug them in, okay? So, negative 3 squared. I'm going here right now. Negative 3 squared is 9 plus negative 3, 6. So that gives me log base 6 of 6. That's what? That's 1 times 2. 2 minus 8. Negative 6. What if you screwed up before you got to the simple equation? But what if you did? Where do you always check your work? Always in the original equation. Yep, just in case. Never know. Okay? 2 squared is 4 plus 2 is 6, and then I'm in the same cycle. 1, 2, minus 8 gets me negative 6. So they both check out. Okay? I think that's a good stopping point for today.